Next, we go to the last type of a material, which is conductor. I believe most of you already familiar with a conductor, where this kind of material can conduct electricity, normally the electric currents. So let's see the properties of the conductor. Conductor basically have very high conductivity. The conductivity related to the flow of electron or currents. So here we can set to be infinity, and we have the value of mu, certain mu, and the epsilon equal to epsilon naught. The loss tangent sigma divided by mu epsilon will be much greater than 1. The skin depth uh, equal to 1 over alpha. The skin depth represent how deep the EM wave can penetrate the structures, okay, or the conductor. And here, alpha and beta have the same expression, which is equal to omega third mu epsilon over 2 sigma divided by omega epsilon. Can be simplified equal to third mu epsilon sigma divided by 2 Newton pole per meters. And the value of the intrinsic impedance equal to third omega mu divided by sigma. And the tangent to theta n equal to sigma divided by omega epsilon approaching infinity. When the tangent to theta n approaching infinity, that means the 2 theta n equal to 90 degrees or the theta n equal to 45 degrees. This is characteristic for conductors. When we observe the graph of the electric field and magnetic field, we can see that there is a phase difference of 45 degrees between both field, where the magnetic field lagging 45 degree behind the electric field. So in terms of the equations, alright, so this is general equations for the electric field. We have mana bendanya? Okay, we have E equal to in the direction of X, E naught, we have exponent minus alpha Z because we have a very high losses in conductor. And then we have the functions cos omega t minus beta Z. This is the propagation directions. For the H field, similarly, we have these lossy components, and the component is at Y, and the same direction of propagation. Here we have the phase delay of 45 degrees. So this is a skin depth, the distance where the wave has decreased 37% of its original value. This is represent the skin depth of the electric field, the penetration of the field inside the conductors. Let's see example 4. A uniform propagating wave in a medium has E equal to 2 exponent minus alpha x sine 10 power of 8 t minus beta z y volt per meters. If the medium has epsilon r equal to 1, mu r equal to 20, and sigma equal to 2 m holes per meter, find alpha, beta, and magnetic field. So basically, you are given the E field. This is the lossy components or attenuation components, and this is a beta. This is the direction of propagations z, and this is the oscillating component of E. This is not X but Y. So that's why I said you have to uh, observe the equation carefully. Right, this is another extra information about the material given, and this is basically the answers. So how we can obtain this answer? So we have to see one by one. Okay, to determine the loss tangent of a medium, we use these formulas. Loss tangent equal to sigma divided by omega epsilon equal to 3 divided by 10 power of 8 multiplied by epsilon. Epsilon equal to epsilon naught because given that epsilon r is equal to 1, so epsilon equal to epsilon naught. In your calculator, this is basically constant 32. Okay, so the value is 8.854 10 power of multiplied by 10 power of minus 12. This is basically epsilon naught. Okay, so when you calculate, you got the value of loss tangent 3388, which is a very big. Okay, very big. And we have to write down the general equation of magnetic field. We know that in conductors, so the difference is only we have the phase delay of theta n, and we also know what is the theta n. Theta n is a 45 degrees. This is what we know, and let's prove it. And you also have this is the attenuation components, and h naught also can be determined. So how to define how to calculate the intrinsic impedance? The magnitude equal to um, this is omega mu. So the omega mu divided by sigma equal to 28.9, and the direction of propagation here is basically um, the AP equal to AE cos AH. We know that E is Y and AP is Z. So this is X, Y, Z as usual. This is the rotation, the sequence. So Z is equal to Y, basically cos minus X, because in this sequence. So basically the answer is minus X. And then this one is 45 like we expect, but we can prove it because the tangent to theta n equal to 3881, which is very big. So the reverse tangent is around 90 degrees, and half of it is 45 degrees. So it's proven. And alpha equal to beta equal to this is a mu, and then this is a omega, this is sigma divided by 2. So you got 61.4. So put everything inside the formulas or expression. We got uh, minus 69, exponent minus 61.4, sine 10 power of 8t minus 61.4 z minus 45 degree in the direction of x. Because we have minus x here, so you put minus milliampere per meter. Something not showing is the how we determine the h naught. It's not given here, but the h naught is basically E naught divided by the magnitude of intrinsic impedance. So you have to divide E naught. In this question, E naught is 2. You got 2 here. So 2 must be divided by 28.9. 2, this one is 28.9. You got 69 milli, okay, the value. So we settle here. So as a conclusions, we have the 4 different type of media, which is firstly the lossy mediums. For the lossy medium, the sigma is not equal to 0, it has certain value, and the sigma divided by epsilon, omega epsilon is much less than 1, and it has a phase difference of theta n, the lagging, the h lagging e, the rest is almost the same, the propagation direction same. Okay, this is um, the e and h always perpendicular. And then for lossless mediums, so the sigma is equal to 0, no loss. And then we can see that the E and H is in phase. For the free space also the same, no phase difference, both in phase, except the difference is only this. The intrinsic impedance is almost the same for free space, which is 377 ohm. Lastly, for conductors, we have the very high sigma, means it can conduct good currents, and then the sigma divided by omega epsilon is very big, and we can see that between E field and H field we have the first phase difference around 45 degrees. Hopefully you can see the difference between all type of medium that we discussed so far.